Alright, so go ahead and pause and read this. The main thing to remember is that, I didn't write this here, is that after you flip the second fraction, you multiply, right? So that's how division and multiplication of fractions work, is that you just multiply straight across, okay? But if you're dividing, you have to flip it first before you multiply straight across. The thing is, it is much better to factor and cancel diagonally, to factor and reduce before you multiply. And so here's a fraction example, just a regular old fraction example, to illustrate that point. So if you're going to multiply this, you get 360 over 525 if you just start multiplying, okay? And then you have to reduce this, which is a pain in the butt. I mean, really, okay, I know I could divide these by 5, I guess. So that would be 105 on bottom and 72 on top. And then we still could go some more. I could divide by 3. See how much this stinks. This is, challenging. All right, we divide by 3, and then we get 24 over 35, and then actually that's it. That's actually as far as you can go. All right, but it really kind of stunk. I was doing it all in my head, and I'm pretty good at doing math in my head. It still was kind of rough, all right, to do it. So it is a lot smarter to reduce first. So let me just try to do the same problem, okay, but reducing first. And keep in mind, how we reduce or simplify rational expressions is by factoring and canceling. That's the first thing we did in the chapter. Here, you kind of can maybe do it mentally. 40 and 25, if we cross cancel here, we go, this becomes 8 and 5, okay? Divide this by 5, divide this by 5. Here, so we're reducing first, really, when the numbers are a lot smaller, so it's easier. That's basically what it boils down to. Okay, is that it's easier to do it first because you're dealing with smaller numbers. Similar deal with, when we do the actual problems here that you're going to be expected to do in, classwork. Here we can do 3 and 7, and then lo and behold, we do 3 times 8, 24, 5 times 7, 35, and let me maybe separate these a little bit because it's looking a little busy. Same answer. Okay, and this is confusing. Get rid of that guy. Same answer with way less mental arithmetic here. Okay, or easier mental arithmetic. We had to reduce a couple times, cross cancel, however you talk about it, however you referred to it in earlier math classes. Same answer because it's the same problem. Easier to get there. Same thing here. You have to cancel. You have to reduce the fractions first. And ultimately, that's where all the work comes in. When you actually multiply, it's weird because you're multiplying and dividing. There's not really a lot of multiplying and dividing. It's all the factoring and canceling out first. And then you can multiply at the end, and that's the easy part. Okay? So I'm not going to spend a lot of time talking about how you do the factoring. I'm just going to do it. That's why we spent all that time factoring in Chapter 5, is that so that you guys feel fairly comfortable with this. So if you are freaking out when I just write the answers, the factored answers, pause it and do the problem. Say, yeah, okay, that's Mr. Owens not just making stuff up. All right. So this problem here. So this is multiplication. So I don't do anything. I'm not going to have to flip anything. Okay. So I just start trying to factor and then cross cancel, reduce, whatever term you want to use. So I go piece by piece, and so it's really like up to 4 factoring problems. So it kind of stinks. You're not going to have a ton of homework practice on. I'm not going to give you a ton of problems because they are all kind of long-ish. So the first one, the numerator here, there's nothing to do. You can't factor that, so I'm just leave that alone. On the bottom, and here's how I'll show the work. I'll just kind of show the factored stuff. I'll factor it down here. I'll factor it below, factor it, right by where it is. So the factored version of x squared plus 3x minus 4 should be, and then, if you don't trust me, do it yourself, x, it ends up being plus 4 and minus 1. That's how you factor this, okay? So just believe me. Do it yourself with the AC method, or whatever method you learned when you learn how to do these. And then we go up here, and it doesn't matter. We can just do them all in any order here. This is factorable 2. And this is x. This ends up being x, plus 3, and excuse me, x minus 3. There we go. Forgot the answer. X minus 3 and x minus 1. If you factor that out, you get x minus 3 and x minus 1. And then last but not least, you get, this is an easier problem. This is 3x plus 5. And then, so then, that looks bad. Let me fix that. So then once you get everything factored, that's the hard part, really. I mean, so I've kind of skipped over the hard part, but you should know how to do the hard part. It's, a matter of the new thing, the new idea here in this lesson, or one of them is that you got to know that you're supposed to factor. You're supposed to factor all the polynomials that you see and then see what happens. And if you do it right, you get to cancel a whole mess of stuff. So x minus 1, x minus 1. If it's on the top and bottom, you can cross cancel. That's exactly what's going on up here with these things here when you cross cancel up here in the the arithmetic problem, the multiplying of fractions. Same concept, only it's polynomials instead of just regular old numbers. And then here and here you can cross cancel as well. And so what's up? The actual multiplication is the easy part. You just multiply, okay, remember that's a 1 left over here, right? So it's 1 on top times x minus 3 on top. So it's just, we multiply straight across, just like here, we did 3 times 8 gives us 24. We do 1 times the x minus 3 gives us x minus 3. Just like here, we do 5 times 7, we get 35. In this problem, we do x plus 4 times 3. And how you'll see it in the back of the book, I think, if I recall correctly, is usually they will actually multiply, they will actually distribute, which, I mean, it really makes sense. These are multiplication problems. You should actually multiply. Don't leave it as 3 times x plus 4. Actually distribute, so it's 3x plus 12. And there you go. I'm not going to circle that. That looks horrible. There's the answer. Let me rewrite it. 3x plus 3x, so 3 times x plus 4, so it's 3x plus 12. Okay, and that's the answer. Alright, I'll cheat. The answer. There's your answer. Circled. Circle your answers, guys. It makes my life easier. Alright, so let's do a division problem. So I should have typed this out because I'm going to be irritated rewriting everything, and so what you guys got to watch the math. Actually, you know what? I'll pause it, okay? Because the first thing what you do is you got to flip the second fraction to the reciprocal. It's the first move you do. So I'm going to pause it and write all that out to save you the pain and suffering of watching me try to write all this out. All right. So there we go. We just flipped the second fraction and changed it to multiplication problem, just like regular old division of fractions that you learn at some point in elementary school. It's just a big complicated, they're all polynomials instead of just regular old numbers that are involved. So anyway, same thing, you just got to factor stuff. And so let me change colors up a little bit. Let's mix it up, let's use purple for no good reason. Alright, so it's actually, this is kind of a mixture of two different types of canceling. This diagonal where it's just x squared next to the fifth is pretty easy, relatively speaking. It's the other diagonal cross-canceling that's a little bit of work because you do have to factor. So it's x, this works out to be x plus 2. It's actually x plus 2 squared. I'll write them out separately. Doesn't really matter, I guess. And then here we have, that's a little weird looking, so we can factor out a GCF like I always say to look for. Oh, no, minus, that's important. Not plus 4, it's 2x, and then x squared. Well, I'll go off the side. Let me go off the side and do this because it's a multiple step and I'll get busy. So, I'll get messy if I try to do it all in there. So then we have x squared minus 4 left over. And of course, that's a difference of squares. So we get 2x and an x plus 2. X minus 2 that's a minus 2. Okay, so that's the factored form. So I just write the factored form above. x plus 2, x minus 2. Okay, and then we just start canceling stuff out. So it becomes, let me change to the standard cancel color here. Cancel, cancel. Okay. And then actually, if you think about it, we have x squared and x. So it's x cubed on top, right? We can actually cross off the x squared and x, that's an x cubed, and then this becomes x squared. All right, so let's think about it. There's 1, 2, 3 x's on top. There's 5 x's on bottom. So the x cubed and x squared, there's x squared left over on bottom. There's 2 leftover x's on bottom. And then last but not least, we can cancel these guys. That's a 1, and that's a negative 5. So, oh, that looks a mess, but we're about home free. So it equals, these colors don't go very well together. I apologize, those of you who are sensitive to such things. What's left? It is kind of a mess. So 1 times 2 times x minus 2. Okay, so 1 times 2 times x minus 2. So actually, I'll just write that down. 2 times x minus 2. And then what's on the bottom? X plus 2 and x squared and negative 5. So it's negative 5 x squared times x plus 2. And you really should, like I said, you kind of need to multiply it out. You need to distribute. So the final answer here is 2x minus 4 on top, and then an 5x cubed. Actually, shoot, this is potentially confusing, so let me pause for a second. How you usually write a or negative, if a negative, you usually don't write a negative in the denominator. So before you actually move on to this next step, you got to think, okay, think of this as a positive divided by negative. When you do positive divided by negative, the whole answer is negative, so you write it out in front to denote the fact that the whole answer is negative. So I'm not going to really distribute the negative 5x squared. I'm just going to throw the negative in front because that signifies the fact that the whole answer is negative. Because think of it as a positive. Think of it, I think it's helpful to think of it as positive on top divided by negative on bottom in this case. So your answer is negative. Okay, so you're really only distributing the 5x squared. So we have 5x squared plus, or excuse me, it's 5x cubed plus 10x squared. And I maybe need to address that in class, but the video is already getting pretty long, so hopefully we are good to go. And then that is your answer, this guy right here. Alright, so hopefully that's helpful. Some of these are pretty tricky, and we'll practice a lot on Tuesday.